this lecture the kinds of carbonyl compounds, the polarity of the carbonyl functional groups, general reaction of carbonyl compounds, nucleophilic addition reaction, and nucleophilic substitution reactions. Okay, so you can go to the next slide. Okay, so all carbonyl compounds contain the acyl group. Actually, the acyl group is the carbon oxygen double bond. Okay, this is the common in all carbonyl compounds. Which the thing which makes them different is the X, the substitution attached to the carbonyl, okay, acyl group. So the all nature of the compounds are depending. The X can be aryl, alkyl, alkene, or alkyne, or even hydrogen in case of aldehyde. Okay. Next slide. These are the in the basis of X. If the X is H is then aldehyde. If X is carbon chain is ketone. Carbon chain can be simple carbon chain or this can be the aryl group as well. If it is OH then became carboxylic acid, and if it is chlorine then it became S chlorine or bromine, then it became acid chloride, or and then if it is X it became ester. Ester can be open chain or it can be the cyclic ester like coumarine. Okay, it can be acid anhydride when is connected with the OCOR, and it can form a lactam when this is attached with the NH2 or NH substituted. Okay, primary or secondary amine. Next slide. Carbonyl compound may be grouped into two broad categories based upon whether they take part in the nucleophilic substitution reactions. Actually, what happens in the nucleophilic substitution reactions is that the nucleophile attack to the carbonyl group, and the carbonyl carbon oxygen double bond is break up. In the color you can see, in the red color you can see the double bond of the carbon is oxygen double bond is going up, is became oxygen negatively charged. The new nucleophile added in the carbon, then the Y is became as a living group, and the double bonds come again. So it means that carbonyl acyl group break and regenerate again its form and leaving the other groups. This is called nucleophilic substitution reactions. Okay, it's only happen when your Y group is a good living group. For example, in case of acid chloride, acidic anhydride, and amide, it is possible. Okay, from where because Y group should be stable. If it is not stable, it cannot live. Next slide. Aldehyde and ketones having hydrogen and carbon chain, because they are relatively not very stable when there is a negative charge put on them, so they can never be work as a living group. So we cannot expect from these two groups to have a nucleophilic substitution reaction. So we can say that aldehyde and ketones are not having the electrophilic substitution reaction, while the others carboxylic derivative can do these reactions. Okay, because why? Because hydrogen and carbon chains are very poor living groups. Okay, they cannot live if for example the tetrahedral intermediate form, but because the Y group of the aldehyde and ketones are very weak or very poor living groups, so it will reverse back. It will not uh, form the product after the elimination of the living group. Okay, next slide. So acid, carboxylic acid and the derivative carboxylic acid with some heteroatom of oxygen, chlorine or nitrogen nucleophilic substitution reaction are possible for these carbonyl compounds because the electronegative heteroatom can stabilize negative charge and form good living group. Okay, we can see the examples. Next slide. So we first discuss about the polarity of the carbonyl groups. Actually, always remember that what is the polarity. This is the very important thing all organic students must remember, because it's very important whenever you are going to discuss the chemistry of the any chemical reactions. Because why the molecule react? Why the alkane chain do not react? The carbon-carbon single bond with all hydrogens do not react because their bonds are almost non-polar. Only the polar bonds have tendency to break and make the new bonds. Okay, so this is very important in the organic chemistry. You must master yourself that why how we can see the which compounds are polar or which compounds are not polar. So always remember that electronegativity is important to know about the compounds. If you know the electronegativity chart of the all compounds, you will be able to see that the oxygen is highly electronegative as compared to carbon. Okay, then what happened when the most uh, electronegative atom sharing the electron with the less electronegative atom, they, because they are the sharing electrons, so what is the done by the more electronegative atom, it's pulls the electron towards itself. Okay, so the carbon becomes slightly deprived of this its own lone pair which is shared by the oxygen. So carbon, we just for the imagination is considered that it gets slightly positive charge, and in case of oxygen which take the electron cloud towards itself is get slightly negative charge. So this makes them polarized. Then it means the two polars are created, positive and negative. Now they are a good uh, center for the reactions. Okay, so on the oxygen side, nucleophile oxygen react with the acid, and because this is negatively charged, so this only can react with the positive charge. Okay, electron deficient species like nucleophilic oxygen can react with the acid because acid have only proton. Okay, and electrophiles. While the carbonyl can, while the carbon can react with the electrophile, carbon react with the base and other nucleophiles. Okay, so attack of the nucleophile always be on the carbon. Okay, whenever you are trying to make the mechanism, so always remember that nucleophile cannot attack to the oxygen because negative charge cannot attack to the negative charge. Understand? Okay, next slide. So general reaction of the carbonyl compound, nucleophilic addition reaction and nucleophilic substitution reactions. Okay, go to the next slide. There are two different ways in which the nucleophile can add to the carbonyl compounds. Each way lead to the different nucleophilic addition reaction, but the mechanism to both involves the first step same. Yes. Okay. So nucleophilic addition reaction can be the two type, but the first step for them for both is the common that there is the addition of nucleophile into the carbonyl group. Okay. The next step what can be done, because you know that when the carbon oxygen bond is broken and this became tetrahydron, then this became sp3 hybridized carbon oxygen bond. Okay, then what happened, there is a two possibility, then the water can be eliminated and it's become carbon and the new nucleophile is a double bond in case of amines, or it can be treated with some other nucleophile to replace the water molecules and then it became alcohol. We will see the example because you cannot understand by the wording. When the examples come, you will it will be easy for you. We go to the next slide. This is okay. You see here the nucleophile attack on this. This became tetrahydral intermediate. Okay, and then the protonation occurs and this became alcohol. Okay, so this is called nucleophilic addition reaction. This is the one way. Okay, go to the next slide. Second type of nucleophilic addition reactions, in this what happened, first nucleophile attack like the NH2 attack on the carbonyl group, it formed tetrahydrid intermediate, then proton shift take place, it became carbinol amine. This is not very stable, so it will eliminate water and then became is amine, or this is also called as ship base. Okay, so this is the second way of forming this one. Okay, understand? In both way the addition was there, but the way is different. Okay, next slide. Nucleophile acyl substitution. These reactions do not take apply to aldehyde and ketone because we already have discussed because their leaving groups are very weak. They cannot do these reactions. Okay, because hydrogen and carbon chain cannot leave, so these reactions are not possible. Okay, go to the next slide. Nucleophile acyl substitution reactions we already have discussed previously, and you can see the mechanism again that the nucleophile attack to the carbonyl group. The oxygen go up, form the oxygen sharing electron go up and form the negative charge. Then this kick back, and then the leaving group is leaving, and this became substituted product of acyl group. Okay, next slide. We already have this discussed this. There are the functional groups. If the oxygen, the carbonyl having OH, this became carboxylic acid, chlorine, acid chloride, ester, and acetic anhydride and amide. Okay, go to the next slide. These are the most common carboxylic acid derivative we always see in our daily life, being as a chemist. Okay, carboxylic acid, acid chloride, acid anhydride, ester, and amide. Okay, go to the next slide. Important thing is that always remember, and this simple thing if you remember, it will solve any problem in your daily understanding. Remember that this arrow is showing that this is the least reactive. It means amide is the least reactive, and acid chloride is the most reactive. Okay, so acid chloride can be converted to the acetic anhydride, ester, and amide, but reverse is not possible in single one step. It will require multiple steps to convert amide to acid chloride, ester to acid chloride, or acid anhydride to acid chloride, because reverse is the single step is not possible. But in the down direction is possible that acid chloride can be converted to acetic anhydride in the one step, ester in the one step, and amide in the one step. Likewise, acetic anhydride can be converted to ester and amide in the one step, but reverse is not possible in one step. It requires multiple steps. Okay, because ester and amides are stable as compared to the acid chlorides. And when they come to the ester is the more stable as compared to the acid chloride and acetic anhydride, but less stable as compared to amide. The ester can be converted to amide, but reverse is not possible in one step. Okay, and amide is the most stable. And you can also understand this stability as well from the nature, because you know that from the natural product only amide and esters are occurring. Acid anhydride and acid chlorides are not occurring in nature because they are highly unstable, so they cannot build in the natural product or in the common system. Okay, but as ester and amides are very common, esters are very common in the fruits, amides are very common in the human body in amino acids, and other peptides and other things are very common. Okay, so this is the reason they are very common in the natural products, ester and amide, because they are stable. But acetic anhydride and acid chlorides are not stable, so they are human made. They are not naturally occurring compounds. Okay. Next slide. So reaction of acid chloride, you can see that acid chloride, this is an acid chloride, it can convert it into ester by reacting with the alcohol. It can convert it to the by hydrolysis. It can be converted to the acid. It can convert it to the amide by reacting with the ammonia. It can be converted to the aldehyde by reacting with hydride. And if it's the double amount is treated, then it's become alcohol. Okay. If we treat with Grignard reagent, it will convert it into ketone, and ketone can be converted to the secondary, tertiary alcohol. Okay. So this is the reactions of this. Next slide. The reaction of acetic anhydride can be converted to the acid carboxylic acid itself and ester and amide. Okay, by using the alcohol and ammonia. Next slide. Less reactive towards the nucleophile than are acid chloride or acid anhydride. Cyclic esters are called lactones. Okay, always remember cyclic esters are called lactone because ester can be formed in the cyclic compounds. Okay, So ester can only convert it to amide, okay, or acetic anhydride, or if we treat with the Grignard reagent, it can be converted into alcohol. Next slide. So aldehydes, this is are the aldehyde. This is you can say the open chain aldehyde. This is aryl aldehyde, and this is the very basic aldehyde, formaldehyde. Next slide. These are the ketones. This is the open chain ketone. This is the cyclic aromatic ketones. Okay, you can go to the next slide. Naming is, I think you all know, it's not needed. So because I will share the slide. I will give to the Dr. Imran, and he will share with all of you that you can read it later on. Okay. So we will go to the our topic fast. Okay, you can leave it. Imran can go to the next slide. Okay, let's go. The naming should be finished. Okay, go to the next slide. Okay. So nucleophilic addition reaction of aldehyde and ketones. Nucleophilic approach 45 degree to the plane of the carbonyl and add to the carbonyl carbon. Okay. A tetrahydral alcohol oxide ion intermediate is produced and ultimately protonated. Okay. This is, you see the same reaction, the hydride reacting to the ketones, or can be the aldehyde, and can form this alcohol. Okay, by these mechanisms. Okay, go to the next slide. The nucleophile can negative charge or a neutral. If the neutral, the nucleophile usually carries a hydrogen atom that can be subsequently be eliminated and carry away the positive charge. Okay, these are some negative nucleophile, and these are some neutral electrophile. Okay, they can react with the acyl group. Okay, so these are the few example of them. Okay, go to the next slide. So reactivity of the aldehyde and ketones. Always remember that the aldehydes and ketones are, in the case of both, the aldehydes are more reactive as compared to ketones. The reason is simple, because the aldehyde having only one carbon chain backing the carbon, okay? But in case of, you can see that this is the carbon, this is the second carbon, because aldehyde always is the terminal of the open chain. Okay, if you are having the open chain, it will be always on the terminal, because aldehyde cannot be go inside the chain, because this having this is shape is like that, it can always on the terminal of the chain, so it always having one carbon attached to it. Because this carbon is slightly positive charge, so stabilizer is only one carbon. In case of ketone, you can see that the ketone is always sandwiched between the two carbons. So it is more stabilized, because there are the two carbon backing its stability of the positive charge. Okay. And second thing is that there is a less electronic hindrance in case of aldehyde, because there is only one carbon chain. But in case of two carbon chain are interacting with this nucleophile, but in case of this, only one carbon chain is interacting with this, and this other side is only hydrogen, which size is very small. Okay, so it makes the aldehyde more reactive as compared to ketones. Okay, go to the next slide. This is the same thing which I explained here. You can understand again this. You see that this is only one carbon stabilizing carbon positive charge. In case of ketone, two carbon are stabilizing this positive charge of this carbon. Okay, that's why aldehydes are more reactive as compared to ketone. Okay, go to the next slide. So addition of HY to the carbonyl group, reaction of the carbonyl with Y is electronegative, gives an electron direct product, and the reaction is reversible, because the electron Y is good leaving group. Okay, this is we already have discussed. And in case of this is only possible the Gregoire reagent. Okay, so we will just have the two slides of the amines, because we are going to discuss in the next few slides about the amines and carbonyl reactions. So it is important, you must know. Actually, the amines are the derivative of ammonia. You know, ammonia is a nitrogen nitrogen having triple hydrogen, okay, three hydrogen, okay. If the one hydrogen replace of ammonia is became amine. If the two replace, it became secondary amine. If three replace, it became tertiary amine, okay. Because the number of carbon chain attached to the nitrogen decide about is primary, secondary, and tertiary, okay. So this is a primary amine having one carbon chain, secondary amine have two carbon chain, and tertiary amine have three carbon chain, okay. The primary okay, this is okay, go to the further detail. So tertiary alcohol is, you can see that this is tertiary butanol, okay. You can see that this one, one, two, three having this oxygen, okay. This oxygen is or having the three oxygen, and but when they come to the amine, this is primary amine, okay. So note that the distribution of the is different as compared to the alcohol. When we are going to, don't be confused with the alcohol and this one, because this alcohol is a tertiary alcohol, okay. In the classification of primary, secondary, tertiary, in case of alcohol is different, but in case of amine is different, okay. In case of alcohol, if the oxygen OH is attached to the carbon which is this attached with the only one carbon, it's come primary. If alcohol is attached to the two carbon, the carbon which is the sandwich between the two carbon is become secondary. And if it attaches to the carbon which is attached with the three carbon, it become tertiary. But in case of amine, the system is different. In case of amine, the nitrogen should have attached with the three different carbon to count as a tertiary, okay. Understand? So this is the basic thing to be understand, the difference between the classification terms of the tertiary, okay. Okay, go to the next slide. So there are the few other examples of the amines, aliphatic amines and aromatic amines. Okay, I don't want to go in details of amine chemistry. That will be which consume over more times. Okay, go to the next slide. Okay, our topic amines and enamines. Okay, amines and enamines are very very important reactions in the medicinal chemistry. A lot of medicines and a lot of reactions, and they are also considered as the building blocks for the synthesis of the complex structures. Okay, amine is a compound that contains a structure unit like this. Okay, nitrogen carbon double bond. Enamine is a compound that contains a structure unit double bond attached with the amine. Okay, so always remember that the amine is formed when there is a amine is a primary. If in amine form, it need to be the secondary. Okay, so you know that what secondary, what primary. You already know that if nitrogen is attached only one carbon and it react with the aldehyde and ketone, it's always form amine. But in case of enamine, it need to be the secondary carbon, okay, secondary amines, so that can form the enamine. Primary amine cannot form the enamine, okay. The both type of common can be prepared with the reaction of aldehyde and ketone. You may have also noted that there is a very famous reaction to identify the ketones and aldehyde, Brady's reagent. You might have done in the your early studies in the laboratory. What we do, we take the 2,4-dinitrophenyl hydrazine and put drop wise over ketone and aldehyde, and we see that they gradually form the yellow or orange and red precipitate depending upon the nature of the aldehyde and ketone and what kind of the conjugation they have, because the colors is depending upon the number of double bonds it has, okay. Understand? So we go to the next slide, we will discuss them in detail. Okay. Aldehyde react with primary amines to form amines and ship bases. Okay, the reaction of aldehyde and ketone with amines or primary amines form amines derivative, also known as ship base. Actually, this reaction was first discovered by the Schiff, so it's put on under the name of it. Okay, so always remember that whenever we talk about amines, so remember that the thing first thing in our mind is that carbon nitrogen double bond. Okay, always remember that. Whenever there is the imines, understand carbon nitrogen double bond. Okay, so you see that this is primary amine reacting with aldehyde or ketone. What you will see that this oxygen is replaced with nitrogen and having double bond, and the R chain of the amine is always intact with it. So simple, this is water elimination reaction. Okay, we can say, also can say that this is condensation reaction. Okay, go to the next slide. Predicting the product of enamines, we can predict any reactions if we know that the first thing we have to always keep in our mind that when we are converting, convert the OH on the carbonyl into the nitrogen. Simple is that. Okay, just put in place of oxygen nitrogen. What we need to do second thing is that whatever the substitution was on nitrogen, just put that one. This finish. This is the simple reaction. Okay, you can see that this is the benzaldehyde reacting with the methylamine form this product. Same way this butanol react with this and form this product. Okay, going down next slide. This is the mechanism of the reaction. This is always remember that mechanism of the how many types of imines form, the mechanism remain constant. All will follow the same procedure. So you only need to master yourself on the one mechanism. This means that you have got the mechanism all of the chemistry of the imines. Okay. What will happen? The lone pair of nitrogen attacking to the carbonyl group. You see that the lone pair of nitrogen attacking to the carbonyl group and the carbon oxygen double bond is break up, and the oxygen became negatively charged. Okay, and nitrogen became positively charged. In the second step, the proton shift is take place because the nitrogen is negatively charged and there is oxygen which is the highly electronegative. It is negatively charged. So what will the transfer shift will be there? This compound became neutral. Neutral compound is more stable air compared to the as compared to the polar molecule. Okay, what will happen again in the second step, because these reactions always take place in the acidic condition, so acid is always there. Okay, this lone pair of oxygen taking the hydrogen again, proton again, and became positively charged. So this oxygen is having positively charged. Positive charge on highly electronegative is highly unstable, always remember. So when there is a highly electronegative group and having positive charge is highly unstable and it wants to be stable. So what will happen? This bond between the oxygen carbon is break up and the lone pair of nitrogen attack to the carbon again and it's form this intermediate. Okay. Then what will happen? The counterpart of the acid which give the proton here will take its proton back because this is the catalyst. In the catalyst, always remember the mechanism, the definition of catalyst that it not consume in the reaction. It only helping the reaction. Okay, so this is the true, because in whenever you are trying to do the mechanism of the any chemical reaction, always remember that if you are using the catalyst, you have to show in your mechanism that catalysts work first to initiate the reaction and then terminate the reaction. If you can't do this, then your mechanism is not complete. Because I told you, in case the acid is a catalyst, so it was used and it was recovered back. Okay, because catalyst is not taking part in the reaction, is only facilitating the reactions. Understand? Okay, Imran, go to the next slide. The other examples of the amines. Amines can form from the primary amines, of course, can form hydroxyamine, form oxime. It can react with the hydrazine to form hydrazone. It can react with semicarbazide to form semicarbazone. Okay, these are the most common reactions are taking place in the daily organic chemistry for the research. Okay, go to the next slide. Okay, the pH of the reaction involves the pH of the reaction involve because I always remember that these reactions are acid catalyzed reactions. Okay, but acid catalyzed reactions are not very high, like you can use the sulfuric acid or nitric acid or this not very high acid. because the pH range is nearby 5. Okay, so better to use acetic acid in these reactions. Okay, if you do not use any acid, your reaction will be not proceed. Okay, it will be very limited reactions. So always remember, these reactions proceed when you are using acid, or if you try to do this reaction on base by using base, is not possible. It will not be done. So always remember that this reaction, if you want to get the good yield and complete your reactions, you always use the pH around 5, which is close to acetic acid. So that is the best solution of catalyst for these reactions. Okay, go to the next slide. Reaction with secondary amines to form enamines. Okay, the most aldehyde and ketone react with secondary amine to product known as enamine, alkene plus amine. It should be noted that like acetal formation, these are acids catalyzed reversible reaction in which water is lost. Secondary amines form a distinctly different functional group after nucleophile addition because they lack the second hydrogen to, because the problem with the secondary amine is that it have only one hydrogen. It cannot form carbon nitrogen double bond because one bond of the nitrogen is attached with the carbon chain. Okay, so what will happen, this will first we will see in the mechanism. Okay, when we go to the mechanism, because that will become clear. Okay, go to the next slide. This is the prediction, how we can predict the our products. First of all, we can put the carbon chain like this as we have, then put the nitrogen amine, and then we can put the double bond between carbon carbon. Okay, this is the simple way of doing this. Okay, so this is the mechanism of the reactions. Secondary amines undergo nucleophilic addition reaction to form neutral tetrahedron intermediate. Okay, then this proton shift is taking place. Then what happened, the acid, because I told you this acid catalyzed reaction, the acid is protonating here. Okay, then this became H2 protonium ion. This is the highly positive charge. What will happen, the lone pair of nitrogen go to the carbon nitrogen between them, and then this eliminated. Okay, then this will form this. Understand this? The nitrogen having the positive charge, what will happen if the nitrogen having the positive charge, the carbon chain is giving his proton to this system, and this be regenerated. Okay, then is form this one. Okay, understand this one? Okay, okay, go to the next slide. Okay, these are the few reactions we can see from here. Okay, first what you can predict from this one, the product A. What can we predict from this? Can anybody tell? This is a simple. Yes,
Imin?
yeah, this will form imines. Yes, good. So that will be the carbon. This oxygen will replace the nitrogen. Rest of the things is remain same. Okay. In case of this one, B, because this is also primary amine. Am I right? Primary amine reacting with aldehyde is, what will be the product?
Also Imine.
I mean, yes, good. And this is the third one is it's oxime because we are consider only this nitrogen NH2. What is attached with the NH2 is not our problem because we are only having the primary amine. Just replace the OH. Sorry, oxygen and just become attached here. Okay, this became oxime. And here in the case of this one, this will become hydrazone D. Okay, you can practice later on because I have the key at the bottom. You can get the key. Okay, so try to get yourself practice on this. Can you run go to the one or two slide back? Yes. Important thing which you need to understand is very important is that you see here this is carbonyl and this is alpha and this is alpha hydrogen. Always remember that enamine can only form when there is a alpha hydrogen available. If you are reacting with any ketone or any aldehyde which do not have alpha hydrogen, enamine will not form. Understand my point or not? Because in the second step, the alpha hydrogen involved. The next to the carbonyl, if this, because for example, there is a OH and there is a OH in a molecule, then what will happen? Enamine cannot form because the alpha hydrogens are not available. Okay, is it clear? So also keep in the mind this thing. Okay, so alpha hydrogen is important, and because these are the very simple reactions, in some cases when there is a different portion of the ketone, and you can say 5 chain, 7 chain, 9 chain ketones, there is the two of the possibilities is there. The double bond can be formed between the 3 4 nitrogen, and these are the other things you need to master yourself on these things. Okay, always remember that whenever you are dealing with the enamine chemist reactions, you have to find the alpha hydrogen. Alpha hydrogen is there or not, because here are the two possibilities. This form can form this way, or this can double bond can form here as well. This is the same thing because this is asymmetrical compounds. And always remember that when the cyclic compound having on alpha place methyl group, this reaction is not possible. Can anybody give me the answer why this reaction is not possible? When this cyclohexanone having methyl on alpha position, this reaction is not possible. Why? Yes, Imran.
Yes, doctor.
If this having the alpha position, there is a methyl group, this reaction is not possible.
Both sides.
Only if having on the one side is not possible.
Uh,
Because
okay.
the reason is that always remember that the double bond is in a one plane. Okay, double bond is always in one plane. If the methyl is there and this methyl, this whole group will be on the same plane, there will be a steric adherence. Understand? So in the same plane, these two bulky groups cannot be take place. So this reaction will fail. It will not form. And- Okay. This is the case of cyclic. If it is open, there is the two possibilities can be possible that one side having methyl and other side do not have the methyl. So the product will form from the side which do not have the methyl. Because it is a cyclic, it is not possible that it can form on the either side because it's in the same plane. Okay. Understand my point or not? The problem is that I cannot share the chem draw with you. Otherwise, I could draw and tell you the how to do this. So you can read about it. Okay, this is advanced things which I am telling you because these are the few important things. You know what happened? These Enamines reactions are usually taking place in the total synthesis. These are the intermediate. These are the things are used to protect the carbonyl and later on regenerate for the further reactions in the scheme. Okay, these are the very important reactions. Okay, go to the next slides. Finish this one all. This we already have discussed. These are the key of this one. Okay, you can practice yourself at home. Imran, share with this slide with all students.
Okay, doctor, sure.
Okay. So, do you have any question? You can ask the questions about this presentation if you have any question.
Are you done, doctor, with your presentation?
I do not understand. Yes. Yes, finish
Are you
almost.
finished?
Yes, finish.
Or you still have something else to present?
That is only the same thing, repetitions. Okay, I do not. We
Oh,
already have
okay.
discussed.
Okay, so I open the slot lah, to all students. If you have any question to ask Dr. Taha, okay, maybe something involving the mechanism or anything related to the nucleophilic addition reaction, because we have basically finished with this chapter, supposed to. Okay, so I believe you should have lah some questions. Any question from the students? No. Doctor,
Yes.
uh, I think maybe you can explain a bit on the difference in terms of the function of catalyst. When we perform nucleophilic addition reaction, right? In
Yes.
general, so we have the use of base, sometimes the use of acid. Is there any effect when we use these different catalysts, different types of catalysts?
Actually, it's very good question. Actually, always remember that the catalyst is depending upon the type of reactions. For example, if you are, what is your byproduct? Okay, sometimes it's based upon the what is your byproduct. Sometimes we say that catalyst they are not truly catalyst. Okay, sometimes they are really catalyst. For example, when we are treating with the acid chloride with alcohol and from trying to form ester, and we use base, in this case, the base is not the catalyst. We are using base to neutralize the acid generated by because acid will be the chlorine will be eliminated from the acyl group and hydrogen will be eliminated from the alcohol and that form acid chloride. For neutralizing this acid chloride, we use base. So this is not called as catalyst. So students should keep in the mind that when we use the term catalyst, it should be a true catalyst. Okay. Sometimes we are wrongly saying something is a catalyst because that is not a catalyst. That is reacting with the byproduct because we do not want the acid to remain in our product. So what we do, we use the base to neutralize the acid. Okay. In the vice versa, sometimes what happens, the acid is used to neutralize the base is generated in the reactions. Okay. Understand my point? Though, so student can understand that when there is a catalyst or when there is not a catalyst, the simple thing is that if the reagent you are using is regenerating again in the mechanism, that is catalyst. If it's not regenerating and it's the end product is different than your catalyst, it means that that was a reagent, not a catalyst. Understand or not?
Okay, I think the explanation is very clear, doctor.
Yes. So
A nice
always
one.
remember, because you know that the most important thing which the Dr. Ataur Rahman used to tell us that uh, always use the pencil and papers to draw the mechanisms. Because practice yourself on the mechanism. Once you become the good having the good practice of mechanism, And you, because if you use the right chemistry and draw the mechanisms, there are the many possibilities. Okay, but your chemistry should be okay. You are completing the octet, you are putting the negative and positive charge at the right places, and mastering yourself by doing this. Okay, if you do not practice on the mechanisms, you will never understand the chemistry. To understand the chemistry, try to play with the mechanism, use the pages and pencil, and try to draw by yourself. Okay, because by practicing you became the good chemist.
Okay, doctor.
Okay.
Can I ask another question?
Yes, 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 of course.
Just to make the students clear, I basically know the answer. Okay. Basically, when we have like C double bond O, then we deal with some negatively charged nucleophiles, and some of the nucleophiles are neutral, right?
Yes,
Okay. Is there a difference between these two nucleophiles? Okay, where in terms of the mechanism, maybe the nucleophile can attack the carbonyl first, or we need to activate the carbon first when we talk about the difference
yes.
in the nucleophile.
Actually, sometime what happens, this is like a trigger where we have to play the trigger. Okay, when, because initiation of the reaction is very important. Okay, so we must know that, always remember that when we say that nucleophile is negatively charged or having, because always remember that nucleophile when negatively charged, it must have its positive counterpart, because in nature negative and positive species do not exist without other counterpart. Okay, when we talk about negatively charged, it means that it has some positive counterpart, but that is like we are using salt, like sodium chloride, like sodium bromide, sodium cyanide. Okay, so there is a counterpart of it, but it is not proton. Understand? But like for example, I am using sodium hydroxide in case of water for the reaction. Okay, so what is the counter? Because always remember that the sodium positive charge is not going to attack oxygen more effectively as compared to my OH negative. It's going to attack to the carbonyl. Of course, the sodium will attack to the carbonyl, attach to the carbonyl oxygen as well, because that is negatively charged, because sodium need to stabilize itself as well. Understand? But because I told you these things, student will think when it do in the real uh, ex- mechanism of the reaction. Because if there is a mechanism, if I am using sodium hydroxide plus acid chloride and forming the product carboxylic acid, now I need to draw, when I try going to draw the mechanism, I have to use where the sodium will be. I have to fit. It's not like that I totally ignore the sodium, because sodium is there and which need to stabilize itself, because that is positively charged. Okay, the why this is given, the neutral mean that is having hydroxy, okay, or having hydrogen attached to this. But when we talk about negatively charged, it means that its counterpart is must be the metal. Okay, it's not possible that is existing only in the itself or the negatively charged. Okay, understand?
Yes, very clear, doctor. Okay, any question from the floor? Okay, so there's no question, I guess, right? Okay, so I think that's all for our session. Okay,
Okay.
so before we end the session, we should take a photo together. So I would like to request everyone to turn on the camera for a while so I can take the photo.